So I'm an ex-English teacher. I've lived in Japan about 12 years now. I'm really enjoying the full stack development and augmented reality. I like React, and I've had a brief introduction to Rust and AR Core. I love pastries, art galleries, calisthenics, and meditation. Okay. So my hopes for this talk is I want to introduce augmented reality to those who don't know a lot about it, and I hope I can meet some other people who are really interested in it too. And hopefully I can also introduce a basic setup to using augmented reality and AR Core on an Android-based system. Okay, so what is augmented reality? Augmented reality, Wikipedia defines it as any perception of reality, any augmentation of reality, whether that be haptic, audio, touch, visual, or directly into your nervous system. So here you can see a recent example of where augmented reality was used to create essentially a memory cloud in the States, made by Google. This was like a memorial event where you could upload pictures and video in commemoration of it. It's said that augmented reality originated in two places. One is the US Air Force, when they used it to manipulate robotic arms in 1992. Another is said to be Boeing used it as a sort of a headset for, they projected lighting so that workers could wire the inner frames of airlines. Here are just some examples of augmented reality in everyday life that we have at the moment. There's the Google Home, Alexa, Magic Leap 1, and just our smartphones. And some people have trouble differentiating between augmented reality and virtual reality. Virtual reality is like a 360 environment around ourselves, while augmented reality is an overlay. So in a virtual reality environment, for example, if it's, say, a Star Wars, it would be 100% Star Wars, while augmented reality will always have our reality plus something. So I'm really interested in AR for this reason, because there's always this element of context, like lighting, like if the weather changes, if the lights change. At this point in time, we don't know how to design things that are appropriate for that context. It's a completely new environment that we haven't really decided the UE rules for. Like with Word or in a normal PC platform, we've essentially, a lot of those environments have sort of been almost explored. So it's like essentially a new frontier for us to explore and we'll develop new rules for. So the original idea for this project was partially because of the Tokyo Olympics. I thought it would be a good idea if there was some form of augmented reality tours. Whenever I've gone to a place, I often find it very hard to organize my schedule to what local times require. So I thought it would be very convenient if we used augmentation here. Another reason is my parents, whenever they visited Japan, they've often had a lot of trouble getting reliable information. Like, even in a World Heritage site, the translations, whether they be in English or any other language, are often kind of mediocre. But that has improved over the past 10 years, but I really think augmentation could enhance those situations especially. So for this project, I wanted to create a poster, a virtual poster that I could place anywhere. Was my MVP, essentially. So I started with web components because those were like what I was most familiar with, and then I moved on to JavaScript and finally AR core. So this is where I started. I've got a brief demonstration, hopefully. And this is a web component that's available on any browser at the moment. It can be used on any Android platform. It's not currently available for iOS, but on Android it's supported on any environment. So you can essentially load, with 2 lines of code, you can load any 3D model. Sorry, I'm just going to give a brief demonstration of it. Okay, so this is that model loaded, and you can place it in your environment by simply, and there you have it. Yeah, you can essentially place and see a properly scaled model very easily. And this is available now in current technology. Okay. Then I went on to Viral AR because I was familiar with React, and this is a library written in React Native, and it's very, because I was comfortable with React, I figured it would be an easy step for me or an easy platform for me to use. And it was. It was reasonably good. It's a little bit delayed. It's about 1 year behind current technologies. And I have a Pixel phone, so I really wanted to use the best that I could. So finally, I moved on to AR Core. Now, AR Core is an SDK on iOS, Android, Unity, and Unreal. But as I mentioned, I wanted to create a poster. So in order to do that, I needed to ask myself how does positioning work? So I'm going to start with a brief explanation of what the AR Core camera does and how it works. So according to the explanation on the library, AR Core uses a process called concurrent autometry and mapping, or COM, to understand where the phone is. Now, I didn't know what any of that meant, so I had to look it up. So COM essentially uses the camera on your phone to grab point clouds. These are points that it finds reliable on your screen. It grabs a number of frames of these points and monitors how they change over time. It uses this information as well as the IMU on your phone, which is just a sensor for the acceleration and the well, the pitch, what way your phone is essentially moving, and puts these two pieces of information together to place objects in your camera using a set of transformations and position the object in virtual environment. My next step essentially was looking at, well, in order to put a poster anywhere, I had to look at locations, and there are three ways that the AI core has to position things in currently. One, this isn't part of AI core, sorry. But this is another way that locations can be placed. Geolocations like in Ingress can be used to get the coordinates, the longitude and the latitude. There's free libraries that are currently very popular. One is like Google Cloud, Google Maps, you've probably all heard of it. Mapbox is another one. Ingress uses Mapbox. Pokemon Go uses Mapbox. And OpenMap is an open source one. But inside of AI Core has a concept of trackables. And a trackable is something that you can position any virtual object upon. So there are three things that can currently be trackables in the AI Core library. One is a plane. So using the similar technology that I mentioned before to get those point clouds, it can also detect planes, surfaces that it can place an object upon. Another is an augmented image. Here was another recent usage where you register images inside of a database and you can essentially project anything upon that. So I have another demo. This is something I built using Android. It's just a very basic demonstration. Sorry. Okay, so whenever you use AI Core, you have that helpful hand which is trying to tell the user to essentially hold the camera slowly. Now here you can see those dots, which are places that the library says are available to project an object upon. So my demo, it's just a very simple demo. It's just projecting a couple of objects. As you can see, you can project office type gear. I'm especially proud of the platypus here. This was my first time using Android and Java, so I had a lot of trouble like learning, getting over that hump, and learning the build library and what to do. So it did take me a while. I didn't actually get the MVP, like I didn't get to post-it level, but I think I will get there very soon, but at the moment I'm not there. Just a couple of things that AI Core is limited by at the moment. There's any environment that, like fluid, water, it has lots of problems projecting upon. Any surface that's very white or shiny, it also has problems. Depending on the lights, you may have noticed, like it's hard to use, and it has difficulty sensing those light differences. There's also some interactive limitations, like you need a clear line of sight, you need to be within 10 meters of an anchor, and I find it a little bit confining. But at the moment, I'm really excited about, like, there's a 60 AI, which is a firm it's a startup in San Francisco, which is trying to create an AR cloud, essentially an overlay on top of our world. They're using crowdsourced mapping to create virtual environments around the entire world, which will really open the platform to be able to be used more in a variety of ways. And I really see it as an opportunity to really explore and experiment with things we aren't sure about. Thank you for listening.
So first of all, thank you so much for coming. I'm really excited to talk about AR. It's a topic I'm really interested in, and more specifically web, and how I think it's a platform that most brands can take advantage of when they're using this technology. First, a little bit about myself. I'm Wil Andrade. I'm a full-stack software engineer. I've been an engineer for a while now. I started off with game development, making games. The last 4 years or so, I've been focusing on marketing. I worked with Google on their AdWords and DoubleClick products, doing their dynamic remarketing ad rendering software. And I came to code Chrysalis because I'm making a move here to Tokyo, and I thought that would be a great place to start and kind of update my skill set on the web side of things. So, just a fun fact. 100 years ago, that's the first time AR was mentioned. L. Frank Baum, he's also the same author who wrote The Wizard of Oz, and I thought that was a fun fact. Now, when I talk about VR, AR, XR, there's so many different terms now, and the way I like to think about it is VR is something that takes you anywhere, and AR is something that can bring anything to you. Right? You put on, when you think about VR, you put on goggles, you're transported into this new world where everything around you changes. AR is more like bringing stuff to where you are, whether you're using your phone camera or any other device like Lens, or if Elon Musk has any say, maybe like tapping chips into your brain. But I think AR is an interesting technology because it's a lot more pervasive than VR. Right? It's something that everyone can already use right away. You just point your phone camera somewhere and you're engaged in that experience. Now, we have many examples of industries that have taken advantage of AR. The first big one was Pokemon Go with 1 billion downloads, and some people around me, they think, it's just a fad. Now, actually, even now, 147 million CCU, which I think is amazing. And retail is taking advantage of it as well. Zara, using AR experiences to show what dresses might look like in real life. You have IKEA using it to let users preview what that furniture might look like in their living room. So all of these companies are using this and boosting sales, boosting engagement, and helping their business grow. In media, you have Snapchat, reality lenses. 7 to 9 million people out of 13 were attributed to coming to that app to check out the new lenses. And that might not be me using that. Anyway, yeah, it's big business, right? It's a technology that's not going to go away anytime soon. $90 billion is what CAPTCHA estimates it'll be by 2022. Forbes did some research about like what marketers and advertisers, what they're trying to use. You know, we have a lot of different types of inventory, but they found out that engagement rate for AR experiences and the amount of time that they engage with your brand grows a lot when you have interaction, when you have this kind of content, AR content. So it's here to stay. It's not just international, here in Japan too. NTT Docomo just invested $280 million in a company called Magic Loop, and it's only estimated to grow going forward. Some other companies investing a lot of resources in it. They have all the big players. So it's something to keep an eye on if you're interested in this. So traditionally, right, you go to a theater, you can see a poster, but I think this kind of content like just screams how much more it could be. Like I mentioned, a lot of engagement, and when we're talking about the web specifically, you don't need to make any downloads. It's very easy and fast to create compared to a native app, and it's viral. You have social media that you can share directly to, and billions of potential users. So AR is already a proven fact, but in my opinion, web AR is a big part of how this technology can grow because it's so pervasive as well. I think it's like extremely useful in terms of how it can enhance experiences, right? It's educational. If you're teaching your kid about how any concept, if you're in a museum, you can point a camera to a dinosaur skeleton, and when you point your camera to it, you can see the actual, what they look like when they were alive, or what we think they look like. It's immersive. It's like right now we're talking about phones, but in the future you put the goggles on and you see everything around you. Me personally, just last year I went to Himeji Castle. I'm a big fan of history and castles in general. And this stood out to me because I thought it was an amazing experience. People can download an app and they can get more information than they would have if they just visited the castle without this, right? They can see a full map in 3D of the castle. One thing that I thought was really cool, there was this room where you had samurai hiding, and they were talking about it, and I couldn't really understand what they meant about this trap door holding a bunch of samurai just in case somebody got in. But when you point your camera to it, you can see exactly where they came out from and see a video of that happening live. And I thought, this is the future. Unfortunately, it's the whole thing about web versus apps, right? A lot of users, they don't want to download an app for every brand that they interact with. Web, on the other hand, you visit a link, it's there, it's instant. Some of the things that you can use today to build AR on the web, AR.js, Argon, WebXR specifically, I think that's the new standard in terms of browsers, and both Google and Microsoft are working very hard on making that the new standard for just normal web. No installs, nothing, having it work across different platforms. But for today, because WebXR is still in development, it's still in beta, it's not really available for mass audiences yet. But we have this tool called AR.js, which I chose to use today to demo some of the things you can do. So the reason why I chose that, one, it's very fast, 60 frames per second. It's web-based, which, as I said, is where I think most brands can take advantage of it. It's open source, so you can take the code, you can modify it, you can do whatever you want with it, and it follows standards. It works on pretty much any phone, maybe any phone in the last 2 or 3 years, and extremely easy to use. So if you've done any 3D before, if you've done WebGL, OpenGL, it's kind of a hassle to set up a scene and set up a 3D environment, but using A-Frame and ARJS together, you can set up a scene this easily. So this here is how you would set up a box, and I thought, how could you make this so simple and still work? I was a little bit skeptical, but as you can see here, just that code that I just showed you on the screen can like let you do stuff like this really easily. As you can see, it works right off the box. Now, one thing that I didn't mention was AR.js is a marker-based technology, which could be anything. I use this here, which is a default marker, but it could be your company's logo, so that every time they see your logo, if they point the camera to it, they'll see a different experience. And just in terms of computing power, this is a lot easier, right? On the web, you don't have as much access to the camera as on native. So when you have markers like this, it's a lot easier. But there are a lot of use cases where you can still leverage this technology. I'd like to show you something that is particularly cool. So let's say you have static media on a poster, and you don't know when they're going to see it, but you can still change like what they see every time they point their camera. Like if you have an Amazon poster, and this here could be either a coupon code or anything else like that. And since we're on the web now, like you can put pixels in there. You can find out who's visiting, who's engaging with your brand. You can create lookalikes on Facebook and a lot of things like that. I thought that was really cool because you can change what gets rendered at any time. You just set it up on your server, which images get served, what text gets served, and it's extremely useful in my opinion for marketers. So I have another experience here. There's a movie I'm really looking forward to watching. This is a trailer for The Joker. So imagine you're at the train station, right? And you're waiting for your train, and there's a poster for the Joker movie, and you just point your camera to it, and now you can watch the trailer as you're waiting. And if you don't want to wait anymore, you just leave and watch the rest. There's audio, full streaming. If this was a game, you could stream the game live as you're pointing the camera to it, and it's just so many different types of experiences that are possible with this technology. One that I really think is cool is, imagine you go to a museum or to a planetarium, and you're trying to tell your daughter, like, this is how the solar system works. And she looks at the image, there's a sun and there's planets around it, but she can't quite like understand what it is. But imagine if she could just like, if she could just see it live. Like she points her camera to it, and now she can see it. Obviously, right now I'm using this piece of paper, but imagine this at room scale. Like how kind of cool that kind of technology can be. This is what this technology can be used right away. It's very simple to build. I built this in like 15 minutes, and there's no reason why brands cannot take advantage of this today, in my opinion. Yeah, just it can handle like different types of technology too. I have a car there, but I didn't quite get the materials to work yet, but it's something I'm planning on getting to work soon. So, just as I was mentioning it, rich media, I think that's a key to improving marketing experiences, right? You can use different triggers. Here I have this marker, but this could be anything. This could be something that gets triggered every time you point your camera at a logo. It could be done with facial recognition. You can do it with barcodes and QR codes. It could get triggered when you're in a specific location in the world. And the type of content that you can deliver, it's massive. Videos, streamable media, 3D models, coupon codes. text, anything. So that's pretty much what I had to show in terms of AR.js. There are a few other resources that you can look at. There's WebXR, which is coming. As I mentioned, it's still in beta, but there's this app, WebXR Viewer, which is just a browser that has that API being modified as you go. And I have a little demo of that here. But I would have loved to show you this because it's really, really impressive. I was showing you a lot of QR-based or marker-based technologies, but WebXR specifically, this is a new API. It's still experimental, still coming, and when you're trying to mirror your phone, it can be a little bit tricky. But for this here, there's a lot of different experiences you can use, and if you visit their website later, you can see some demos that are possible with it. As I said, it's still being built right now, and I personally, I like to dive into these kinds of technologies when they're still in this kind of phase, because it can contribute to it. It's something that allows you to shape how web is being built and how these experiences can be made in the future. And if you're interested at all in this type of technology, I recommend checking it out and giving it a shot. And just as a final point for my talk, I think like because of the cloud, the computational types of things you can do are increasing a lot. You can make experiences better and better by using the rich local environment to capture data, to use the camera, use audio, and then send a lot of that computation down over to the cloud. As a matter of fact, just recently I was working on this English teaching app where you take a picture of your environment and then it labels things that you're seeing using computer vision AI and AR. And yeah, I'd love to show that in the future as well. But yeah, that's pretty much it for me. I just wanted to show what's possible with this technology right now. There's still a lot to come, and I'm really excited about it. So hope you check it out as well. I'm new here in Tokyo. If you like to talk about this kind of stuff, I'd love to meet up. Feel free to email me. I'd love to get in touch with everyone. Thank you so much.
Okay, so good afternoon, everyone. Good afternoon. It's 2:30. Okay, so good afternoon, everyone. Thank you for coming the big MiniConf today. And some of you already get a good experience of the presentation before me. But also, I hope you guys get good new experience through my tech talk today, Emotional AI. So let me talk about that. But before that, let me talk about myself. So nice to meet you, everyone. My name is Go Nakano. I'm super pure Japanese, as you already recognize me. Yeah, I'm super Japanese. And I have a hobby actually, play drums and also snowboarding. The reason why I bring my hobby, the second part of my profile, I have the reason. Actually, I want to create some application app to creating, the connect music and something. So when I like make the music application, I want to add some more like technology. It's not only like a play music or play some songs. It's already like a release, right? So when I think about some another like extra, right? And then it is giving the idea of emotion. Because when you're listening to music, I think you guys already have experience to getting some emotion, right? Like when you listen to music, you're feeling happy, or you're feeling so sad, or when you gigs, you got like some like a nice song, and then sometimes suddenly like crying. So emotion and the music is kind of like a tight connection, and then it's making so like interesting, make me so interesting, and I'm really eager to make this app. That's why today I talk about the emotional AI. Yeah. So then I'm starting the coding since last year because I want to make my application myself. And then I have the interesting about recognition AI and emotional AI. And then I have the motto: do first, think later. So that's why I want to make the application, but I need some technology to understand. So I suddenly quit the job in this year and then joined this code Chrysalis to running the coding. So do first, think later. I don't know in the future, but hopefully future is nice. And I have a career, 5 years working as a salesman in the automotive industry before I joined code Chrysalis. So that's all myself. Okay, so let's talk about the emotional AI. So today I provide 4 contents. The first is the introduction. So just talk about what is AI, emotional AI, and the history of some of the AI. And also how the emotional AI recognizes our emotion. So I'm going to talk about that. And then I showed some demos. So today I provide 2 demos. One is connecting the Microsoft API, and the other one is running face recognition in my machine itself. And then in the last part is I'm going to talk about more emotional AI, where it is using, and then what is the future of the emotional AI. Okay, so let's go to the first part. So introduction. What is AI? History of the AI. What is emotional AI? I'm going to talk about that. So first of all, do you have any idea that what is the AI stands for? This is already the answer actually here. Sorry. So artificial intelligence. This is stand for artificial intelligence. This is like the branch of computer science. So one of the computer science, especially dealing like a simulation of the intelligence behavior of the computer. So imagine like the computer having like the behavior to do as if like a human does. So I think you might notice some of the like idea. For example, like a Siri. When you talk to the Siri, and then Siri responds back as human does do, right? So this kind of the behavior, also the machine having this kind of behavior, it's generally called the AI. And also the capability of the machine to imitate intelligent human behavior. All right. So then history of the AI. The AI is starting like a 1950. One of the scientist guy, it's called, whose name is Alan Turing. He do one test, whether machine can trick the people. And after this test, the AI, the definition of the AI is expanding the world. And then some of them are creating like one machine which is called ELIZA. It is the pioneer of the chatbot. I'm sorry, the small sentence you cannot see, but this ELIZA is what they do is they are like receiving the like how do I say like chatbot. So we talk to the ELIZA, and then ELIZA responds back chatting. So it is the kind of pioneer of the chatbot, and then we can communicate with the machine. And then after that, the Shaky is coming. So this is kind of like an AI robot. So there is the monitor here, and then in between this is the hardware, and then there's a loader in the between, in the bottom. And then what does this is like kind of AI robot moving around based on the monitor they are catching. So monitor catching the location, and then understand where they are standing, and then it's moving around. They are passing the AI understand the location and the direction. So these 2 ideas is bringing to the here. For example, do you know eyeball? Does anyone know about eyeball? All right, cool. So someone knows already. So this is kind of like a toy of the dog toy is kind of here. It is also including the AI inside. So this dog it's kind of like do the behavior as dog does do. For example, I talk to the dog. Of course, dog cannot respond, but moving like so funny things, and then also they are the display to showing his emotion itself. And then also the Roomba. I guess some of you already have in your home to do, yeah. The Roomba is kind of like a cleaning machine to understand and then moving around, and then based on the monitor, and then understand their location, and then also cleaning. So once Roomba hitting the wall, for example, they understand they're hitting the wall, and then looking for the direction to go next, and then keep cleaning. So what I want to say in this slide is, this AI is starting in the 1950s, but after 60 or 70 years already, it is already inside your real life, right? So this Roomba is already in your phone, and then some of the iPhone users using the Siri, and then also the Alexa is in the home, and then controlling whatever we are saying to we are request. So as you may notice, so everyone have an experience to touching the AI itself already in this current year. Okay, so then what is emotional AI? So emotional AI is of course one of the AI, artificial intelligence, and especially this AI is study and development of system and device that can recognize and interpret the human affect based on the face information, and then also voice and gesture. For example, if I show like this kind of face, oh, I'm so nervous now, I cannot display but when I show this one in front of the computer analyze my face information and they understand, okay, this guy might be happy, and if I do like this kind of face, and then of course nothing understand because of the position of the lips is how to say, machine understand this kind of sad face. And also voices, if I say I'm so nervous, super nervous, something like that, and then this voice tone, and then computer understand, okay, yeah, I understand you are so nervous now, right? And then also body gesture, again nervous, I'm doing like this kind of things now, then I'm because of I'm nervous, so that's kind of things. So these three principles is a basic element of the understanding, I mean for the AI understanding the emotion itself. Okay, so how emotional AI recognize our face? So this is just, as I said, so there's a facial and then voice and then gesture recognition. But today I'm going to talk about the facial one. Okay, so there's generally 4 steps to understanding. So first is a signal acquisition, and then second is a feature extraction, so feature of the face, and then feature classification, and then last part is the evaluation. Okay, so let me talk one by one. Signal acquisition. So first of all, we need to send our image. We need to ask AI to recognize my face or my emotion, for example. What AI needs, of course, my face information, right? Otherwise, they cannot understand, right? So we have to send the data. And then when we send the data, we need to, of course, send this image, but this image is creating each tiny pixel of the face and the image, right? And then when we send this image to the computer, we are pointing the feature of the face. For example, I have the eyelid here, and then, difficult English. Eyebrow. Then also eyes, and I have the nose, and then mouth, and then I have a mustache, and then beard, right? So these feature also, when we send the picture, we pointing this feature itself, and then sending to the AI side. This is the first process, signal acquisition. And then second part is the AI receiving the data, and then what they're gonna do is that they are analyzing the point, and then creating, describing the pattern. It's kind of like a model. So they are connecting each point, okay, and then making this image of the face. Then this is one of the extraction of the, the modeling of the describing the face. It's called the 3D modeling. There's another modeling also, but in this point I'm going to talk about that. Okay. And then this is after making this pattern of the face, they are going to match their pattern inside their the database. So of course in the database, the AI holding the bunch of the information on the face pattern, right? And then after that, after they understand the face pattern, and then they are going to correspond their database data, and then which one is, what kind of emotion they have. And then after that, based on this corresponding, they are pointing some of the position of the face, and then recognize, okay, this guy is in this case is a neutral, right? So this is the general fourth step of the facial, the process of recognition. Okay, so I'd like to show the demo. As I said, I have two demos, but before that, I want to talk about something about how AI study of the face, because as I said, I have the two demos, but the second demo is I want to machine itself to understand my face. Okay, so this case I have to teach them what is my face, who am I. Okay, this is kind of like a process. So in this GIF, as you see. So machine is always looking for the face, and then once they pointing the face, they are stopping a bit, and then check inside the face, so looking for the feature. So generally the machine, this is by the way one of the case to teaching the AI side, and then they finding the face and then looking for the insight to the feature. So a bit more detail. This is my image, the picture, my face, okay, and then first of all, so. In this hair-like features, in this process, they are going to change my image to the grayscale. Okay. The reason why I change the grayscale is because the color, if you have the color, of course, each pixel has a color information, but it is also making the bunch of the image we are having, passing to the computer. And then computer is difficult, computer can understand the image information, but it is bunch of the data we need to send. But instead, if we send the grayscale, it is only like a black and white. So this is more like making faster to understand my face itself. Okay. And then after that, we change the grayscale, and then machine also looking for my face itself. And then in this part, as I said, so they receive the pixel, but also machine reading each one single pixel, it takes so much time. So that's why instead they are making kind of grouping. Okay? And then in this part, they already making the group of face here, and then sum up the brightness. So which part is more lighter or like a whiter, or which part is more darker. And then they making this kind of shape, then judge the pattern. So this part, the face, and then this part is eyes, and then this part nose, and then mouth. Okay. All right. So this then I'm going to show the demo. All right. So this is part of my first demo. So what I'm going to do is first I'm going to take a picture, okay, my face, and with some emotion or some emotion, okay, and then I'm going to send this picture to the Microsoft API. And then API receives this face data, and then based on the face data, they respond back what emotion I have. So let me try. Okay. Good, right? Okay, nice. Yeah. Good face. So good smile face is here. I'm going to send good smile. I'm going to send this nice picture to the Microsoft side. Hope they receive, and then they respond back like this. So in this case, I'm super happy. This part 100%. So I know some of you is kind of like doubting it is really right or not. So is any idea can anyone tell me like which emotion that you want me to do? I have the anger, contempt, and disgust, fear, and also happiness, and the neutral, sadness, surprise. Any idea?
Disgust.
Disgust. Ah, disgust. Actually, yesterday I tried disgust, but it doesn't work. sorry. Just disgust. Right. Oh shit! Let me try again. I think we still have time, so. Maybe. Oh, contempt. Disgust. Yes. You want one more? Maybe I have time. So. Is any idea or other? Again?
Anger.
Anger. Anger. Okay. Anger. Yes. Okay. Then, no. Yeah, it's kind of disgusting. See? Okay. Anger. Right? Yeah. So that's great. Demo, I guess. But what I want to say in this demo is, okay, that I really send this picture to the API side, and then Microsoft understand. I mean, they already contain a bunch of data inside, right? And then they understand that this face information. So, like, what is the lip location? What is the eyes? And then they understand each location and send back the response like this. So this is very, how do I say, so exciting to do that. Actually, you can do that as long as you can get the API of the Microsoft. This is very simple. If you have an interest, just come to me. We can talk about that. So the second demo is, okay, as I said, so I'm going to work on with my machine, not sending the data to the API side. So this time, I provided the two files, train part and then faces part. So this is the just implement part, invoke part, and then this is the trainee part. So I'm going now inside this folder. I have some face information of the other guy. This is some of the famous talent in Japan. So the guy, at least you can see the human. I mean, the guy has a face and with a glass. So I'm going to put. I'm going to run train part first. Python. Oh, I'm so nervous. Okay. No such director Python. Oh shit. Yeah, faces train. Sorry, I forgot the faces train. Okay. So now this program reading the information on the image here, and then show up which image is succeeded to read as a face. So now this machine already understands the face itself. So let me first, let me work on the it's fine. Okay, so there's a webcam. Where is the, oh here. Okay, so at least machine already understand the face part, right? So it's looking for, I mean, it always the rectangle shows here inside, and also they understand the face itself. Sorry, eyes. Then if I, yeah, you see the label, the terminal. So because I only input the other person, but the other person, this person having the face. So what I want to say is this part, at least this machine understand I'm the human and I have the face. So this recognition, it works. Then after that, but this is the other person, right? So I want to input my image. I want him to recognize my itself. Who am I? And then I have this face data. That's so. Never. Okay, so I'm just moving this file, my face image to this part. And then I'm going to run this training again. Maybe I make it bigger. Oh, okay. Face train. Okay. So now its machine is training to understand my face and with the guy who has a glass, right? So there's a two face image inside this data. Okay. Now I'm going to run. Okay. Then, oh, it doesn't work. It doesn't work. Just now. That's kind of. See, yeah, it's coming out, right? So if I do like that, and then you see, it's not showing a terminal anymore, right? It's showing myself. Sorry, I'm doing like this kind of explanation. So as you see in the screen. So my name is showing like that. So this machine is understand my face itself based on the information I input in the data. So that's how recognition works. Is it interesting?
Yes.
Right? Right? Yeah. It's so scary. It's kind of creepy, but yeah. Okay, so this is my demo, and I'm going to talk about more information about emotional AI. So where is the use cases, where this is mainly used for now, and also the future of the emotional AI. Where is this emotional AI going to be used, and then review. Okay, so the use cases, first of all, this one is used for the education. For example, there's one company called BrainPower. They produced one nice tool with the Google, and this BrainPower using the product for the emotion glass for the kids who has autism. You know, so autism kids is kind of difficult to understand the emotion in front of him or her. And then in this case, they produced this kind of this product. So what happened is when the kids wear the glass, they see this kind of monitor through the glass. So this one showing as an error, right? And then where is this emotion come from is based on the data of the face in front of him or her. Okay. So once they wear the glass, they see this screen and then show up the emotion, and then they choose which emotion is correct in front of them. And then they are doing some kind of quiz game, and then through this education, they can learn what emotion the person in front of you having now, and then they can learn, right, what is emotion. So this is nice education example actually. Okay, and then next one is the interview. This is kind of scary for me actually. For example, like one company doing a test for the monitoring the candidate, and then through the monitor, AI is analyzing the emotion and the mood of the candidate during the interview. And of course, most of the cases it's kind of nervous, right? But some case, for example, you're talking about your story or something you know, you are kind of getting excited. And then this part also going to send to the data and then pass to the interviewer. So some of you, I think you have experienced as an interviewer. So when you guys interview, you're kind of having some bias, I think. It's like something like feeling some bias. That's why I hire him. But actually, the guy is not what you guys expected. So something like this mismatching happen, some of the case. But because of this AI analyzing the more like a stable and the neutral, so this is helping the interviewer to understand and how candidate is do the behavior. So this is one of the cases of the interview. Okay. And then other part is the driving. So some of you are also driving sometimes, and then feeling, I think sometimes feeling sleepy, for example. And when you're sleepy, if you have like a partner, of course they are punching you or something, and they can make you wake up, right? But if you know, then you have some risk to having the accident. But this case, or some of the vehicle already has a system of understanding or monitoring the face, and they understand these guys are feeling sleepy, and they're like alerting or doing some action to make us wake up. So this is also using the driving part. And the other case is the marketing. So when you go in like, for example, like a retail shop. So retail shop also some doing this analyzing of through the monitor. So looking for the consumer, and then which part, and then which moment, like a consumer feeling more exciting or more happy, or feeling some like positive things. Like when you see the when you're looking for some like clothes, you're feeling smiling, and then they're catching this part. Oh, maybe this clothes is kind of like a demand. Or if when you see, for example, like a commercial, and then when you're feeling so, how do I say, there's some like face changing or sad or happy or something like that. And then based on this image or based on this pattern, AI sending to the marketers to analyzing which moment consumer having more attractive to the product. It is also using as a marketing. So one of the features, this is not a video by the way, this is just a picture. Actually this is already used, but this emotional AI also using by the security. So based on this face information, as you can see here, there's a neutral, happiness, surprise, disgust, afraid, and anger, sad. So there's an emotion also shows. So now, for example, like when you're in the airport and then in the immigration, especially the Haneda airport, I think when you go into Japan, you already see some face recognition, right? then I think this face recognition already have like just judging the how to say the person's face, but also this might be have the like this emotion case to be secure the how to say the terrorism inside the airport or whatever. And then in this case, like Haneda case, they only use the immigration now, but maybe this kind of like security things is also happen during, I mean the whole of the airport is kind of like through the monitor, and then guys like how to say walking inside the airport and then do some terrorism, for example. And then this guy is having some like a different or weird emotion, and then recognize that, and then it's also alerting the system and then security to, I mean prevent to happening this kind of accident. Okay? So this is also this is kind of one of the future of the emotional use. So, okay, the review. So what is emotional AI? So emotional AI is one of the AI artificial intelligence focusing to the emotion based on our face information, voice, and the gesture. Where it's used is education case, like the kids for autism, the nice class, and also the interviews, and also driving part, and then marketing wise. And then future of the emotional AI, maybe more security wise, it sounds for me it's kind of scary and creepy because every time I have to care about the camera. So personally I'm kind of scared, but it is kind of a feature. And then how to recognize our face. So there's a 4 steps, right? So I'm going to send the image of the face and then pointing out our feature, and then based on the feature describing the face itself, and then correspond data, and then send back to evaluation. Okay, so that is the 4 step. Alright, so that's all to my tech talk. Thank you so much for your attention.
Hi everyone, so my talk's methods to increase your privacy. It's a very basic talk. It's not going to get into great detail, but I hope I can help to just give you a little bit of the context of security and encryption, and maybe give you some advice about how to secure your data. So, my name is Scott Angus. I come from Canada. I'm going to be returning to Canada after leaving CC. My hobbies include photography, woodworking, piano, and finance. I do some derivatives trading for fun. It's very exciting. I used to be a competitive person. I used to sail competitively, dinghies and keelboats, and I used to play computer games competitively. I played tournaments in Toronto, Montreal, New York City, and Dallas, Texas. And I used to play chess competitively as well. That's enough about me. I want to talk about security and why security is important to me. So security breaks are not a myth. I personally have had my personal security violated. Around 10 years ago, I had someone get into my email accounts and use those email accounts to get into all of my social media accounts. And all of my personal messages to everyone, all of my emails, all of my photos in those accounts were open to whoever hacked me. Their IP address was from New Jersey. So it was not a good feeling, and I don't think that you should have to experience the same thing in order to learn my lesson. So they're common, they happen across platforms, and they can be extremely damaging and pretty frustrating. So I want to talk about the assumptions we have about our data and why we might not take it as seriously as we should. The first of which is intentions. It'll never be used against me. The data I have out there is never going to be used against me. So I think most of us have learned from maybe our neighbors or our parents to be physically secure, to lock our house, or to leave our wallet in our pants instead of on a table somewhere. And we realize that it can be stolen, but our information, it's such a new concept and it's so abstract that we're not really sure. We haven't learned our lesson yet, I guess, as a society. So definitely be aware that people are having their data hacked. And the perception is what's wrong today, or what's right today actually, won't be considered wrong in the future. So with that in mind, like if you share political views online, maybe those political views will be used against you. Even small stuff like what team you root for. Maybe someone in your friend group really hates that team and they have something wrong with themselves, that maybe they do something to harm you as a result. So I just want to remind you that like, horrible things have happened for really stupid reasons, like Rwanda, people were killed for their last names, or if you think in Cambodia, the Khmer Rouge killed people because they wore glasses. People do reckless things. And the quantity of data, I want to talk about the permanence of the data that you store. So when you submit your data to a website, say Facebook, or to a company where you buy something like Amazon, that data, you should assume that it's stored forever. You shouldn't assume that it's only a temporary thing. So keep that in mind as well. So now I want to talk about who stockpiles your data. So the first is big business, and they don't really deserve to have your data as much as you might think they do. In the past, they've been pretty reckless in keeping it. And I want to give you a few examples. So the first of which is Equifax. And Equifax is a credit bureau in North America. They're in the United States and Canada. And they've had probably the biggest breach in history for data. The names and birth dates and social security numbers and driver's license and credit card numbers of people got leaked. And this was a massive people, and you didn't even have to be necessarily a customer of Equifax itself. You would just be a customer of their partners. So that was a terrible time for a lot of people because they could have their identities stolen as a result of that information. The next is Yahoo. Yahoo had a big leak in 2013 and 14, and the names, emails, telephone numbers, dates of birth, security questions all got leaked. For a number of people. Initially, they thought it was only like in the hundreds of millions of people, but in 2007, they changed their numbers and they said all of the accounts got hacked, more than 3 billion accounts in total. So that is another big case. Third is Ashley Madison. I don't know if anyone's heard of that here, but that's basically a website used for having affairs back in North America. And they had a data leak in 2014. And so you can imagine if you were having an affair, you really wouldn't want your information leaked whatsoever. But that happened to people, and I think around 4 people were reported to have committed suicide after this leak as a result. So those are 3 major cases. So if you're a developer, data breaches that you can prevent could end up costing your company a lot of money as well. So I want to look at Yahoo. And they were fined $35 million by the United States government. They lost 7% in their share value. They were also in a buyout with Verizon, if I remember correctly, and the buyout ended as a result being $350 million less than it was initially, the initial offer. Also, there was a very limited amount of people who were involved. In total, 4 people were found to be involved in the breach. So it doesn't take a lot of people to get at your data. And like I said earlier, more than 3 billion people were affected, including users, employees who might have gotten fired as a result of Yahoo's poor performance, shareholders, and so on. So can I ask, and does anyone know the name of this man?
He's hiding in Russia now.
He is hiding in Russia. He's being protected by Russia, I guess. His name is Edward Snowden, and he was an American whistleblower. He was upset at the American government, so he was a CIA contractor, or he was a CIA employee, and that's a Central Intelligence Agency. And he was subcontracted out to the National Security Agency in the United States. In 2013, he ended up leaking data. He was a whistleblower, so he was leaking about how much the United States government spies on its own citizens. He did this because he felt that his complaints about how much data was being spied on was not taken seriously by his employers. So he came to his superiors and he said, this is not right, and his superiors basically disagreed with him, did nothing, and so he flew to Hong Kong, disclosed the spying efforts to the media, and has lived in Russia ever since. So I want to read a quote from him. He said, in general, the reality is this: if the NSA, FBI, CIA, DIA analyst has access to query raw signet, which is signal intelligence, databases, they can enter and get results for anything they want. And with this, he refers to the data that they partner with Prism and Upstream, and those are two programs run by the NSA. And Prism is essentially a co-location with major firms like Microsoft, Google, and Apple. So they share data with those firms. And Uplink refers to telecommunications companies sharing data with the NSA. So private companies really aren't the only offenders. Governments all over the world, not limited to the US government, will keep large compilations of your data. So in 2012, as per Snowden, the US government spent $53 billion US on intelligence, and this is a black budget, so it's not itemized, so nobody knows what it's spent for except for the people who work for the government. And to give you an idea of what $53 billion looks like in terms of storage today, that would be about 2.77 trillion terabytes of data. Of course, it's not spent solely on storing data. You have to have employees and people processing the data, but just to give you an idea. Also, Snowden brought up 5 eyes, so technically it's against regulations to spy on your own citizens in most democracies. But to get around that, countries have come up with agreements whereby Canada, for instance, will spy on Americans, and Americans will spy on Canadians, and they'll share the data to get around the regulations. So there's 5 eyes, which includes Australia, Canada, New Zealand, and the United Kingdom, and the United States. There's also 9 eyes, which furthers that with Denmark, France, the Netherlands, and Norway. 14 eyes, Belgium, and Germany, Italy, Spain, and Sweden, and so on and so forth. There's more agreements with many more nations. So don't trust your government not to be spying on you. So we've all seen the picture of this man or woman in the media, the black hat wearing person or the hoodie wearing person who's about to get your data. So you have personal hackers who want to get your data, and they're known as black hat hackers. So they break into networks and they'll write malware and attempt to break into databases and sell that information on the internet. And they do so for personal and financial gain. In contrast, there's white hat hackers, and they do so in an ethical manner so that they can prevent black hat hackers from breaking into your data. They'll inform the companies that they break into, or they'll coordinate with those companies and really share the exploits that exist and try and prevent any data from being leaked. So also there's personal attackers, and those are the people who just want to cause harm to other people, and they target people for harassment, revenge, or other reasons. And so going back to Ashley Madison, I want to give you an example of something that was sent to people. So this is actually letter mail, and I believe this type of mail was sent to at least 12 states in the United States. So they're basically extorting people for money, well, cryptocurrency, and you can read the threat to ruin your life. And that's potentially why those 4 people committed suicide. So getting back to the main topic, how is data protected? It's protected by encryption, and it's protected by encryption in transport and in storage, and lastly in use. And in use is very non-typical. It could be if you're working for a fairly serious company or for the government, you protect your data in use such that if your laptop, for instance, was stolen, there was no possibility for a cold boot attack where they take the memory out of, or the data out of the RAM. But we'll talk more about the first 2. So I want to go over what a simple cipher is and maybe elaborate on that, what symmetric cryptography is, and asymmetric cryptography, and also what hashing is. Because these are all very important concepts. First, a simple cipher. This is a Caesar cipher, and if you put an input like this in for this particular cipher, which just goes down 3 digits, then you receive an output like this. But a Caesar cipher is open to an attack called a frequency analysis. And so this is a frequency analysis for English. The longer the data is, the more likely it is that you can just tell what the message is based on how frequent certain digits are. Currently, this is how more modern encryption works. So you have your key, and it's XORed with the data. So each of these lines represents a bit. And so the number of bits represents like a string of data. Your key is XORed, then it's substituted, and then it's permutated, and so on and so forth, repeated over and over so that your information is scrambled. Symmetric cryptography. So what happens? You have one shared key, and this key can be used to encrypt and decrypt your information. And you can't use this for the internet because there's no way to decide on the key without sharing it over the public wires first. So you have to use asymmetric cryptography, whereby you'll go back to using symmetric cryptography because it's more efficient, but you use this to set up the initial state. So you have a public key which is used to encrypt, and a private key which is used to decrypt, and the public key goes over the network, but the private key does not. And in doing so, you can do Diffie-Hellman key exchange, and so that's where a base prime number, and its modulus are shared. So hashing, what is hashing? Hashing is basically a mathematical algorithm that maps data to numeric strings, and it's a one-way function. That is to say that it's really difficult to go backwards. You can go forwards easily, but you can't retrieve hello world from that number. And the reason why you would use it is to just verify that the data that's being sent to you is correct, that there is no man-in-the-middle attack that's happened. Man-in-the-middle attack is where someone impersonates to being the person that you're communicating with. So they'll intercept your message and send you back a fake message, and you can use hashing to verify. Some of the examples include those, but of those, 3 of those have been broken by attacks, so they can no longer be used. The most recent of which was SHA-1, and that was in 2007, and Google and an Amsterdam firm, I believe, were the ones who performed the attack and broke it. So in transport, TLS, is the protocol used to communicate your data securely. And the client and server communicate using a symmetric cipher after the initial exchange using asymmetric encryption. So that's referred to as a handshake. And the most common is Diffie-Hellman and RSA, I believe. I want to talk about VPNs. VPNs are a service that you can purchase or use. They're not very expensive, and they allow your web interactions to be routed to a third party so that your ISP doesn't share your data with your government. They allow you a lot of anonymity because you can choose which country you want to route through. You have that option. And they can allow you to operate out of a country where they're not friendly with your own country. So say, for instance, for Canada, that might be technically Hong Kong. So these are some suggestions I have for you. 2 examples of VPNs. They're not very expensive, and they're fairly easy to set up and use. And storage. How can you protect your data in storage? Well, you can use encryption, symmetric encryption. The programs will add an interpretive layer between the applications and systems and the low-level drivers used to write to the disk. The data is then interpreted by a symmetric cipher and is encrypted and decrypted using the same key. And some examples include TrueCrypt, BitLocker, and FileVault. FileVault is for Mac, BitLockers for Windows, and TrueCrypt, I believe, is for almost all platforms. So these are some encryption standards in strength. As you can see, key size is either a 0 or a 1. So that's a 1-bit key, and there's only 2 combinations, and you can crack it with brute force. That is to guess naively very quickly. But as you go up in the range, 128-bit, there's 3.4 times 10 to the 38 combinations, which is 3.4 with 34 with 37 zeros after it, I believe. And that would take about twice as long as the length of the universe has existed, using a computer that used to be the most powerful in the world in Kobe, Japan, back in 2011, using a 10.5 petaflop computer. Currently, there's about a 150 petaflop computer in the United States, so you can see that while power is growing quite quickly, it's still nowhere near to being close. So you should feel protected, but maybe not, because quantum computers are becoming quite a new thing, and they really can reduce the amount of integrity that keys have. So you can see here that if you have 128 bits of security on a normal transistor-based computer, on a quantum computer, that would be reduced to 64. And using public key encryption, which is used to set up the TSL layer, it goes down by even a greater margin, about 1/4. So it's very insecure if quantum computers become a thing. And they are developing quite quickly. Currently, there's a 72 qubit computer that can be used for encryption breaking that Google has. But researchers have said that you need about 20 million qubits to break an RSA 2048 password or key within a reasonable amount of time, about 8 hours. So it's complicated to explain how quantum computers work, but there's an algorithm created by, I believe, Peter Shor in 1994, and they rely on destructive interference of the resulting solutions, and they return the right solution using quantum Fourier transformation. And what should you do? So what should users do? I'm going to give you some very simple advice, the first of which is to seriously consider the data that you give everyone. So the companies you give, the hardware that you have on you, you should seriously consider what you store. Because what would happen if your laptop, for instance, was stolen, or someone got in your email, maybe you had talked to a lawyer, and maybe that would be used to blackmail you. And that would not be a great circumstance. So you should think about the consequences of your data being leaked, because it's actually quite common nowadays. You should ensure that devices and websites that you have and use current encryption standards, because like I said earlier, the hashing functions that I talked about earlier, 3 of the 5 have been broken. And those are used to store password hashes in databases. So they can be backwards decrypted using certain algorithms. So you also need to evaluate the trustworthiness of the companies you give your data. So if they've been breached in the past, were they negligent in telling you about it? Did they come up with it immediately? These are important questions to ask. Do they seem to care about encryption, and are they forthright about what sort of systems they have in place? Use two-factor authentication. I know this is really simple and annoying, but just do it. There's no sense in not using it. Also check if warrant canaries have been used on certain websites. So if you're politically, if you have a lot of political discussions, maybe you want to check and see if there exists warrant canaries. And what is a warrant canary? It's basically a piece of text that will tell you if there's been a secret warrant to gather the data on any website. And certain websites do this because you're not allowed to inform people explicitly that you're under a warrant, at least in the United States. And I would recommend using services that are paid, like ProtoMail, because they've promised to use the funds you give them. They're a paid email service, but they promise to use their funds to protect your data. What can developers do? So developers have a moral obligation, in my opinion at least, to make sure users' data does not get stolen or leaked. They should ensure that user password information, this is very basic, is hash and salted and not stored in plain text. Secondly, they should make sure that their website is secure from known attacks like SQL injection and brute force attempts. Thirdly, don't stockpile data you don't need, because you never know if your website will be open to a zero-day exploit, which has never been talked about before. And in the case that you are open to being exploited and having your data stolen, you don't want more data than you need to have. So in conclusion, what does this information tell us about data security? I think you should come out of this with more thought about who has your data and how you protect it. And I want developers really to take it seriously and not leave their data, their users' data, in the hands of criminals. Thank you very much for coming to Tech Talk, and these are some materials at the bottom that I found very interesting that you might as well.
Good afternoon, everybody. I just want to apologize first because of my voice. I was kind of sick, but I'm feeling much better. I'm excited for this Tech Talk. I'm going to be talking about CAPTCHAs. And before I do that, I want to introduce myself. My name is Lucas Kim. I am Korean Brazilian. I'm Korean, but I was born and raised in Brazil. I am an aerospace engineering graduate. Like many other recent engineering graduates do, what I did after I graduated, I did not work with engineering. I went to finance. I worked with finance for about 3 years in Brazil. And it was at my work in the bank where I just sparked my interest in technology, because all my team was trying to automate all the stuff that we did. So, and I was trying to do everything I could so I could go home earlier. So every work I did, I just wanted to automate it, just keep it to the computers. I don't wanna do this. And it just sparked me interest in technology, and I just realized that I want to do this. And so I took a break from my finance job, and I came to Japan to study coding, and I just liked it very much. I'm currently a student for CC9, and my interest in technology nowadays is machine learning, artificial intelligence, and building full stack apps. And just to credit myself as an expert for this topic, I've been coding CAPTCHAs since 2005, so I think I'm pretty good for giving pretty reliable source for giving this tech talk. But let's jump into it. But before I talk about CAPTCHAs, I think I have to talk about how people trying to trick computers using computer techniques. And I'm going back all the way to the 80s when the lead speak language appeared between hackers. What they were trying to do is they wanted to work around profanity filters, and they wanted to write something that computers could not read. The search engines of the time, they were so bad, obsolete. So they wanted to try to work around that and then create something that humans could read on forums and stuff, IRC, but computers could not. So it was the lead speak language was born, and this was in the late 80s. And a couple years later, there was this website called Alta Vista, which was a very, very popular search engine of that time. And they had a spam problem. Like, people were creating scripts and automated programs so they can just spam all they wanted into their database, and they wanted something to prevent that. So what they did, the engineering team at Alta Vista was 4 engineers. They came up with a puzzle that every user at the website had to fill out before submitting a URL. And it consisted of just work with strings and numbers with space, different font sizes, fonts. And it was very hard for bots at that time to solve it, and it was very successful. Well, modern CAPTCHA, however, didn't came until 2003. It was designed by engineers at Carnegie Mellon University, and the team lead was Wilson Lau. I call him the father of CAPTCHAs because it was after their work that they came up with the word CAPTCHA, which stands for, I always get this wrong, completely automated public Turing test to tell computers and humans apart. So yeah, and this was the birth, of CAPTCHA, and what it did was it kind of got the idea from the Alta Vista engineers, but now they had some more strings, and then they had some difficult words that bots could, it was really hard for bots to read it. But humans, like, it's very easy for humans just to look at it and just solve it. So, and why is this so important for us to have CAPTCHAs? It's because nowadays the traffic, the internet traffic on major websites, about more than a half of them are just bots, and this is really bad because if your website or app have any resource of any value, they're going to always be a target for bots because they can post inappropriate comments, they can scalp tickets, they can create tons of spam emails, and we don't want that. So this is why every major website nowadays has CAPTCHAs. And I'll just give like, I'll be, throughout the presentation, I'll be giving scores of how the arms race between humans, web security companies and spam bot creators are fighting. So with the birth of CAPTCHA in 2003, it was very clear that robots at that time could not solve it, and we were just very secure for the time being. And so I gave 1 score for the web security, which is us, humans. Of course, it would be too easy. My tech talk would be done here, and this is not what I came for. I came here to teach you guys how to break CAPTCHAs. So let's break it. Like nowadays, there are a lot of websites. You can just hire people. You can download programs. They're going to solve CAPTCHAs for you. But I think the most effective way to solve a text CAPTCHA is just using technology we have today. I'm going to be teaching you guys how to do it with just 2 libraries. It's called TestRack OCR and RMagic. Starting with RMagic, what it does is, so let's say we have a CAPTCHA, it's step 1 right there, and we want to solve it. So what RMagic is going to do for us is going to take whatever CAPTCHA we have, and it's going to crop it to whatever is interesting for us, and just crop out everything we don't need. And you're going to grayscale it, so any colors you have, like difficult CAPTCHAs with a lot of colors and stuff, we just change it to black and white. After we do that, we're still using RMagic, we remove the small pixels. This is a very important step because what it's going to do is all those lines that's going to strike through the letters or just small points that we don't need, we're just going to get those out. So if you have a number here or a letter, all the pixels are always one next to each other. So if you have like 1 pixel that's not, like it's by itself, we know it's not important for us, not a letter, probably not a letter, so we just get rid of it, and then we get something very clear, which is this. And we just render, just make it a little bit bold, and this all using RMagic is very, very, very easy. After we have that, we can, and by doing this, I just taught you guys what OCR is in a couple of minutes, so this is amazing. It's really easy nowadays. And now, then we use TestRack OCR, which is a tool from Google, it's a library from Google, it's open source. Thank you very much, Google, it's an awesome tool. And to install it is very easy. I am a Mac user, so you can use it. You can install using homebrew or Mac boards. It's just, you just call it brew install TestRack, and then you're done. It's a command line program, so you just call the library using 1 line. In this case, you call it using TestRack, and then you just give it parameters like where the file is, the image file is, and when you want to output it, the result. And you have some other parameters. It's optional. You can choose the language you're trying to read, and some other configurations. I really did run one test here, that image, and I just used tesseract, and then that was the output, which is amazing. It was 100% correct. So you guys remember we had the 16QE90 CAPTCHA that we rendered with Magic. I just run tesseracted. So I call this image OCR disk. I saved it in my desktop. I run this command line. I want to save it as a text file called wow. And when you do that, wow, this is the output. It's amazing. So I just taught you guys how to break CAPTCHAs, and you guys can make spam bots now. So with this technology coming, it was really easy for spam bots to go through CAPTCHAs. So they were catching up, and we need something to stop them, right? And it was very interesting because at that time, when CAPTCHA was created, hundreds of millions of people were using it in their websites, and hundreds of millions of CAPTCHAs were being solved every day. And you should take into consideration that each CAPTCHA a person takes about 10 seconds. And I say that because they have to click on the text box, type the words, think about it, they get it wrong, so they do it again. So it's 10 seconds. And if you see as a whole, the whole humanity was wasting 500,000 hours just solving CAPTCHAs, which is dumb. So, and very interesting fact is like for major achievements of humanity, like we can say like constructing the pyramids from Egypt or sending a man to moon, it kind of 100,000 people were involved in doing all those great achievements. Like, is there something we can do with 1,000, like hundreds of millions of people solving CAPTCHAs together? Like we're all working into one purpose of solving CAPTCHAs. Can we do something greater? And that was what Luis thought about it, and it was a new start. And I quoted him saying, "Can we do something useful with this time? Like our brain is doing something amazing, something that computers cannot yet do." So after some tinkering, he was like, "Oh, what can I do with this?" He came up with Read CAPTCHA. I think many people came across this one. It's the same concept. We're giving 2 words, and then you just type it. If you get it right, you pass it. If you don't, you're a robot, and then you've been blocked. But the key concept here was that Luis was actually getting words from OCRs that I explained to you guys, from automatic OCRs. They were reading scanned books, like all of the books we went to digitize them to make it accessible to everyone on the internet. But some words, because the ink was really bad, some pages, like very old documents, they were like ripped. It was very hard for OCR at that time to read. So what it did is it gave us, the CAPTCHA gave 2 words. So the first word is just like any normal CAPTCHA. The computer knows the answer. And the second word is grabbed from a database from the OCR, the machine learning system, that they could not read. The computer does not know what this word means. So what they did is they grabbed this word, they just strike through it, and then send it to CAPTCHA. By doing this, every time the user answers the first one correct, the computer's gonna think, okay, so I know that this word is a pun. If the user types a pun, I have some confidence that the second word that he types is gonna be right too. So if the user types a pun and between, the computer's gonna learn that this word now is between. And if you do that for a lot of people, solving CAPTCHAs at the same time, the same word, the confidence is just gonna grow, and then we're teaching machines that this word now is gonna be between, and they save it to the database. And this was amazing. I was really amazed of what this did. So we had hundreds of millions of people working together, solving all these CAPTCHAs, and we're probably teaching machines. And what happens is in a few months, all of the archives from New York Times were transcribed to computers. And Google was very amazed by this work too, and in 2009 it bought Read CAPTCHA, and started sending all of the words from Google Books and digitizing them. And it's pretty awesome because a lot of people, probably a lot of us guys, we kind of work for New York Times or Google, just trying for free, the solving CAPTCHAs. And Google just provides those books for free now. And when they ran out of books, they started sending us Google Maps images, like this numbers from the images, like what number is this? Like we can read it so easy, but computers could not at that time. So with this reCAPTCHA, this amazing tool, is the arms race over? Like, are we working together with machines now? And are we gonna live happily after? But no. Because of that, CAPTCHAs are getting more and more complex. I mean, these are fake CAPTCHAs. It's not real, but because we are teaching machines how to read more than words and images, we're actually training machines to get better at it. So it was kind of working the opposite way. We're solving CAPTCHAs to help humanity, but we're also helping spam bots to get more intelligent. So yeah, CAPTCHAs were getting really complex, except for this one, which is easy. I solved it for you guys, so it's 6. It was really easy. So what happened is it was really interesting because in 2014, Google came up. Google had this machine learning being evolved every time people use CAPTCHAs, and they're like, okay, let's see how accurate our machines are now. And they did in 2013 very kind of hard to read CAPTCHAs. Like I cannot read this. And they tested with humans, and humans got an accuracy of 33%, which is, I think, okay, 1/3 of the humans got it. But what was interesting is that the Google Vision AI was getting all the CAPTCHAs 99%. So, whoa, something's wrong here. And so, machines are getting so much better than humans now, and we're getting behind. So, CAPTCHAs are being obsolete. Like, doesn't matter like how many CAPTCHAs we solve when we get it wrong, because computers are getting so good at it. So Google was like, okay, let's do something else. We need to reinvent CAPTCHA. And then they came up in 2014 with what was called no CAPTCHA, reCAPTCHA, which was just a simple checkbox. When you click it and then you're done. And it solved everything, right? Because bots are gonna come up with this, they're gonna be very honest and say, okay, I'm a robot, I'm not gonna click it, I'm just gonna run away. No, not really. So, so what happened is robots, the idea behind no CAPTCHA, reCAPTCHA was about how humans action happened before they click the box. So humans, we are all imperfect, we cannot move like robots do, and the mouse movement of humans is very wiggly and scrambled, and it's very hard to follow it. But bots, they always follow the same pattern. They are very strict, and so it's very easy to distinguish between humans and bots. But now you can ask me like, oh, can we just program bots to move the mouse like this and then click the box? Yes, we can, but that's not the only thing that Google was doing. So what happens is when you click that box, a lot of information is being sent to Google. Not just the mouse movements, but your IP address, the time zone, the screen, the size of your screen, cookies, and I mean, what else, right? Because it's Google, it's getting our data. I don't know what else. I actually tried to see what Google was gathering data from, gathering data from the user. But it's very hard because Google encrypted it twice, and I think it's fair because the more Google just gives what we're gathering, it's just more information for bot makers to do. So I think it's pretty interesting that Google is very skeptical, but it's very cagey about it. So again, what will happen is the user is confronted in the form. You just get a I'm not a robot reCAPTCHA. You click it, you're gonna send a lot of information. Google system risk analysis engine is gonna give you a score based on how your mouse moved and how all the information you got from it. And from a scale from bot to human, if you're lucky enough and if Google thinks you're a human, you just click it and you pass. That's it. You get nothing else. But if Google engines think, oh, okay, so this user is, I don't think maybe he's not a human. I think maybe he can be a bot. You'll be confronted with CAPTCHAs. Still like the old CAPTCHAs, and you just solve it and then you're in. The more bot, the bad score that you get from the risk analysis engines, you get even harder CAPTCHAs. And it was very interesting. I mean, this was amazing for me. It just changed how we thought about CAPTCHAs. And it was very interesting because in 2014, it released it, and 2 years later, bot makers could not still get past it. What happened here is that bot makers, every time bot was confronted by that checkbox, they just ran away. They didn't know what to do. They clicked the box. They didn't know what to do. There's a lot of CAPTCHA they had to solve. And humans were getting 96%. So from 33% of solving text CAPTCHAs going to 96, that's really amazing. And also the solve time for the reCAPTCHA just got from 12 to 6 seconds. 6 seconds, yeah. And this is Ticketmaster. It's just how Ticketmaster, how tracking Ticketmaster got better with after implementing no CAPTCHA. The traffic was really was lower because this was a lot of bots, so it was really good for Ticketmaster. So what happened is with this reCAPTCHA, no CAPTCHA, we actually got in a point that we were kind of even with the bots. But that's not what my tech talk is about. Let's break it again. So I have this video of a person breaking the CAPTCHA. What he does here. So this guy created a robot that's gonna try to check the box. He's gonna get a CAPTCHA back, and using machine learning and some image recognition libraries, he's gonna know that it's gonna look for storefronts. So it has found some. He's gonna click on that, and it passed. So again, bots were always ahead of us again. So Google was like, okay, we have to think about something else. And Google came with something called reCAPTCHA version 3, which is amazing once again, because reCAPTCHA is now invisible. That's why maybe we're not seeing that many CAPTCHAs anymore. And what it does is it's gonna run through all of the websites in the back. It's gonna be invisible. We don't know what it's doing. It's the same concept. Google's never telling us what's gathering, and it's very sketchy about it. So and I agree with it, because you cannot give information for bot makers. It's just one API call. You just register for one key. You get one API call, and you're gonna get a response for every time a user goes through it. And what is important here is the score. So score 0 is gonna be very likely to be a bot, and 1 is gonna be very likely to be a human. I ran this test using, and you guys remember, like I told that Google is gathering cookies from you. So I ran this reCAPTCHA version 3 invisible with an incognito page and just one with my page. And I got a score of 0.3 for incognito and 0.7 as a human. So yeah, it was pretty interesting. So I did not came with a way to break it yet. So I'm giving a score for humans for now. And I think we're pretty much even now with bots with this reCAPTCHA version 3 that Google came with for us. So what are the pros of CAPTCHAs? It's good for stopping bots. We need this. This is something that the web security depends on. We need CAPTCHAs every time. Even though we all hate it, we all hate solving puzzles, I think it's something we need, and it's getting very user-friendly right now. The cons are, so machine is always evolving, AI is always evolving, so I'm pretty sure I don't give more than a couple months that somebody's gonna break it. So this is, somebody has to come with something else. And so what are the CAPTCHA alternatives, you may ask me. I don't know the answer, but I know that Amazon came with a patent in 2017 that's gonna try to remodel CAPTCHA, and what it's gonna do is it's gonna actually try to make something that humans gonna fail. So if you fail the test, you're a human. If you pass it, you're a bot. And this is one example. It's a quick example. I'm running out of time. But if you read this sentence and ask you guys, how many F's do you think this sentence have? If you read it just once, maybe you answer 2, 3, 4, or 5. Yeah, if you answer 4 or 5, congratulations, it's totally wrong. You passed the test. If you answer 6, please talk to me. You may be a bot. And so yeah, I'm really hoping to see what's going to be the future of CAPTCHAs from now on. And I have some recommendations of movies and documentaries. Please watch his tech talk. This is the father of all CAPTCHAs, and it's pretty interesting. These are my resources. I'm really sorry for rushing because I ran out of time, but yeah, thank you for your time. Hi, So the topic that I want to talk about today is decentralized finance with JavaScript. And so I'll give a bit of background about myself first. Just to kind of give you a bit of context about why I'm interested in this topic. And so I have a business background, so I graduated a business degree a couple of years ago. I also have a bit of background in design. But kind of, I recently moved to Tokyo from Toronto. And back when I was in Toronto, I was quite involved with the kind of blockchain community there. If some of you may know, Toronto is actually the birthplace of a technology called Ethereum. And so kind of Vitalik and some of these people who developed Ethereum are actually did it probably a few blocks away from where I lived back in Toronto. And they're actually, I ran into Vitalik a few times in Toronto, just on the streets there. So it's a really, really great community there. I have to say there's kind of a bit less in Tokyo. But kind of when I was in Toronto, I was really interested in the technology, and it was kind of a couple of years ago. And so I wrote a lot. I wasn't really quite the developer I am now. And so like kind of what contributions I could make was kind of in this field of what we call crypto economics. It's kind of like, how do we think about these models, these kind of incentive models that we can create with crypto. And so one of the really interesting ideas is bonding curves, which is a way of raising money through kind of through blockchain technologies. Security tokens, which is essentially using blockchain technologies to kind of put securities or like equities, like stocks, onto the blockchain, as well as kind of this question about valuation. And so there was a lot of discussion about that kind of a couple of years ago in terms of like when the ICO bubble kind of blew up. That's kind of initial coin offering for anyone who doesn't know. Kind of the prices of these tokens basically, like there were a lot of really interesting kind of work around how do we actually assign a price to this? And since I had a finance background, I kind of applied some of what I knew to kind of that and contributed to like all of that. Anyways, you can find my writing on Medium. And I'm happy to talk about any and all of this if you're interested. But I do not recommend or like, please do not come to me for investment advice because that is very, very common in this space. And so kind of why decentralized finance? And it really is this kind of question, like what does permissionless, decentralized, programmatic finance really mean, right? Because that's the promise that like we kind of hear in the news, right? People talk about this all the time, oh, it's so permissionless, it's so decentralized. Like what does that mean, right? In the context of finance specifically. And I think the apt comparison is just to kind of think about maybe the Japanese banking system these days, right? Like if I want to, and I have not attempted to, open a bank account in Japan, it is most certainly not permissionless nor decentralized. They can say no to me like that, and I would not be able to get a bank account or credit card or whatever, right? And that's one of the reasons why this is so exciting, is that we have these big banks who are centralizing this kind of entire process of finance, right? They control your money, they control your accounts, they control your ability to interact with the financial system. And most certainly, again, especially in Tokyo and Japan, programmatic finance is not a thing. I would be very surprised to hear if a bank had an API to somehow access kind of your bank accounts or something like that, where you could use programming to really work with kind of the bank's systems, right? Even with all the security kind of protocols in place. And so kind of what decentralized finance and what blockchain technologies really offer is this concept that we can do this now, actually. So blockchain is a technology that anyone can access, right? So again, I don't need permission to go and actually put a transaction on a blockchain. I don't need permission from anyone. It's like the internet. We can do whatever we want, and it's kind of this open protocol. Again, just like the internet. There's no intermediary. And so when I make a transaction with someone, when I go and borrow money, when I go and send someone money, I'm not doing it through a bank, I'm not doing it through a Visa, I'm not doing it through MasterCard. I'm just sending the money directly to them using these networks. And I can do it using code, which is really what I wanted to focus on. I imagine kind of a lot of us are developers here. And part of this is why this is really exciting is that like it's actually really easy to make some of these transactions using JavaScript. And I think that people are not necessarily exposed to that because blockchain and smart contracts and all this is really is really scary for some people because it's like, oh, there's a lot of technology that we might not know. But I'm going to show you kind of like basically the 3 different tools that you might need to make your own transaction using JavaScript and using code. So let's jump into it. And so just kind of just a quick vote of the audience, like who knows what Ethereum is, has heard of Ethereum in general? Oh, awesome. Who would say they actually know how Ethereum works? Okay, so I'm glad I put this slide in, just kind of a brief explanation. And so Ethereum is a programmable blockchain that enables this using smart contracts. And so let's talk about both of those 2 things. And so this is kind of Ethereum, right? We kind of understand that like blockchain is this chain of blocks. That's what, like it's a linked list, it's all these different things. And how Ethereum works is effectively it's like a world computer. And if you're kind of all developers here, you might understand that like there's different state. It's almost like it has this global database that we all have access to. Imagine you have kind of an app that you build yourself, right? So you have a database that kind of tracks state every time, and you have code that runs that changes that state, right? And so in Ethereum, kind of every block that is mined, you may have heard that term before in terms of like Bitcoin, like you have all these computers that mine blocks. And they mine something we call transactions, right? So like these transactions are just like, oh, change this value from 0 to 1, right? Change the B value from 0 to 1. And so kind of what it effectively does is, again, it has this global state, we can store all this information, and it uses code to manipulate it. And this is stored forever, basically, because it's a blockchain and it's stored by all the computers that run Ethereum. So what is a smart contract then, right? So there needs to be like some amount of code that is actually run to manipulate the state from one point to another. And that's essentially what a smart contract is, right? So it's just code. This might look scary for a lot of people. It kind of resembles Java. It's kind of, again, for developers in the audience, it might resemble kind of what's happening here, right? And so we have, for example, like the declaration of a bunch of variables. And these variables are kind of the state that we're storing for this smart contract. We also have 2 functions, right? We have a getter function, essentially. So what is total supply? So can you get this value? Can you return like what you have stored as a value? You have a kind of a setter function, not really, but it's essentially a function that manipulates the state, right? I want to transfer this amount from this person to another, therefore it changes the state of kind of that you're storing. And so again, this is something that you and I can also write. This is a language called Solidity. And all these contracts are deployed to the blockchain. And so what's really special about smart contracts, and I think this is actually really, really cool, is that you write this code that's kind of in this language, and you have every computer in the network run it. And that's kind of mind-boggling to me, because like at the kind of high points of Ethereum, that meant 25,000 computers all had to run this code to confirm the state of the blockchain, right? Like what's stored, every single computer had to run it. Now it's about somewhere between 7,500 to 10,000 computers running an Ethereum node right now. The second thing that's really cool is that, like, I think a lot of you may understand that, like, I think a general understanding of blockchain is that, like, things are immutable, right? That once you commit something, you can't change it. And so, like, when you make a Bitcoin transaction, for example, you can't reverse it. That's kind of this whole, why it's really, really trusted as a platform. The contracts and the code that you have deployed and written are immutable. And so once you write this code and you say, I want to go and deploy it onto Ethereum, you cannot change it. And that kind of has 2 qualities to it that I think are really interesting. Is that one, like, once this is deployed, anyone can use that code because it's basically publicly available. Like, I can go and call any smart contract that was ever deployed at any time that was created, as long as I know how it works, right? As long as I know what functions to call, because that's not really public information. And again, it means it doesn't change, right? And so you can't have, for example, if we look at APIs, like a company running an API can go and say, oh, like I'm going to change this API. I don't want to give this functionality anymore. That's not something that's possible in Ethereum. Once it's been deployed, it never changes, and therefore there's a kind of a sense of predictability to it. And so what becomes really, really cool and kind of mapping to this idea of an API is that like we can all call these APIs. Like, and I'm going to show you how shortly, is that these are basically open APIs that exist. As long as, like, for companies and projects that want to let you use them, they document, oh, this is actually how our contract works. And as long as you have that documentation and you have the address, which we'll talk about a bit later, we can all call these contracts and make transactions and get data from these contracts. And this is what I think is really, really exciting about what's happening. And again, it's much simpler than I think all of us are led to believe by the media. And so this is kind of the part that, like, that I think a lot of people are also confused about, kind of what does it mean to really be a blockchain developer? And there are 3 layers to that. And so kind of on the very, very bottom layer is like actually developing the blockchain itself. And what that means is that you develop the protocol that's being run, right? And effectively what the people who do this do is like they write the actual software that runs on those 25,000 computers. And like, how does that protocol work? And that is something that I am not able to do to the remotest sense. Like, these are probably some of the smartest people on earth are working on these problems right now to ensure kind of all these different complexities that come from developing a blockchain. I do not recommend anyone to do that. There are many companies who have tried and like, I do not know why. They think they're very smart and they think they have developed protocols that are better, but that is an enormous, enormous challenge. The second part of the kind of logic that exists is kind of smart contracts. It's kind of what we were showing, right? These contracts that exist in the blockchain, again, that are immutable, unchangeable code that anyone can run. And that has its own kind of set of challenges as well, right? Because one, I'm not sure any developers in the room, I'm sure all the developers in the room would just shiver at the idea that you write code that never changes and that needs to be secure and that people can't hack. And that's just a horrifying idea to me. I actually tried doing this at some point in time. And like, I could never have the confidence to go and say, like, I really want to develop this. Because it's, again, people can hack, and people do hack these things all the time. And so kind of what we're talking about today is kind of, can we build on top of those layers? Can we use the APIs that are provided by these contracts in order to build interesting tools and interfaces and products? Because we can actually do that. And I'll show you a product that I actually built based on 2 protocols. And so I'm going to talk about 2 protocols that I use to build a product. This is a really cool protocol called Compound. And so Compound has become kind of one of the more popular protocols on Ethereum. It allows you to borrow and lend money. And that's a very, very basic, interesting problem, right? And what's interesting is that the interest rates that you borrow and lend based off are algorithmically determined. So there's no central bank saying, oh, print more money. Or like, there's no kind of, like, there's no one deciding what the interest rates are. It's purely a function of supply and demand, of what people choose to borrow or lend. And there's actually $160 million on this platform right now, across about 10,000 addresses. Again, addresses don't really map to people necessarily, but it's a lot of people kind of in this ecosystem. The other platform that I'm going to be using is something called DAI. And DAI is like also probably the most popular platform used in Ethereum right now. Is basically a US dollar pegged currency. And so again, we all hear about kind of Bitcoin prices and Ethereum, like Ether prices going all over the place. The community has decided that we really need something that's stable. And so this is something called a stable coin. And so in order to stabilize it to $1 US, this is also done programmatically and also through a set of incentives. And so this is an extremely complicated protocol to kind of go into, so I won't be doing that today. But they actually have 3 people in Japan working on it here as well. And I don't know, Catherine is trying to do a lot of stuff. So anyways, there's $75 million kind of outstanding, and this is backed by $250 million. So again, these are real platforms, real money, and that's why I find it really exciting. And so I'm going to go into a quick demo about kind of what I built, kind of based on these two platforms. The code is public if you want to look at it. And yeah, so let's see. So I imagine some of you haven't worked with kind of Web3, what we call Web3 or decentralized applications, dApps, before. And so this is kind of one of the really, really crucial pieces of the ecosystem, is that like when you work with a decentralized application, you actually need to have like a wallet. And there's a couple, we'll kind of go into a bit more detail there, but I need to log in to access this data that's available on the blockchain. And so I'll just do that really quickly here. This is a product called MetaMask, which we've talked about kind of briefly as well. And so it asks you, like, can I connect to your account? And so this is kind of like directly connected to my personal like Ethereum account. This is a test account, so you do whatever you want with it. But yeah, so you connect, right? And by connect, oh gosh, I don't have internet. That's a bit.
You can connect to the guest.
Yeah, no, it's also a bit. It doesn't like me very much. That should work. So again, I'm still logged in here. And so again, this is kind of now I'm connected, and it's trying to go and grab a bunch of information from the blockchain. Sorry, I must have waited too long to not have an internet connection, I think. There we go. It is very slow. And so this is effectively, so when we build Web3 apps, a lot of time we don't actually need to use a server. So when I get these values and you saw them kind of loading in, they're not from a server that I run. They're from what we call a node, kind of an Ethereum node, where they're from one of the 25,000 computers running this right now. And so that's one of the really cool parts, is like this is a fully front-end only application. And so let me kind of briefly explain the application first. And so Compound, again, is a platform that allows you to lend money, and you get interest based on that. And so I kind of thought that it might be a good idea to kind of build like a savings account, an interface to say, okay, I want to get, right now this is a real number, it is currently 10.5% interest. There is a lot of risk associated with that. I cannot quantify it, but it's 10.5% interest to lend money to this platform right now. And so this is basically a graph that says, oh, if you go and save like 1 million yen every year at this continuing interest rate, how much would you make by the time you're in 2037, for example? And so again, this kind of changes, and you can do whatever you want there. And so I'll kind of show you two really basic functions. So one, this area on the bottom here is my wallet, right? So every account has this number of kind of accounts associated with it, so that's what sits with my wallet. And this is kind of a savings account I have also associated with my wallet. And in order to save money, in order to get interest, I have to transfer money from my wallet to the actual account itself. And so I built in that functionality here, right? So I'll go and deposit like 30, this is equivalent to $30 US about. And you'll see that it actually pops up another kind of one of these notifications. So whenever we make transactions using the blockchain, we have to manually confirm them. And this is kind of the interface that's been developed by some really smart people, wonderful people who have built this for us, that makes it so much easier for us to interact with the blockchain. And so if I press confirm, what actually happens is that it starts reloading. And kind of one of the big problems, or one of the big things about Ethereum, is that like things take time to load and things take time to confirm. And so basically some number of computers in that 25,000 computer network have to say, oh, this is correct, I've confirmed it, therefore I can update your balances. And the more confirmations in that network, the more confidence you have that this has actually gone through. And you can see kind of there's some lag time to that, but again, building interfaces on these platforms is really is difficult largely because of that kind of dynamic as well. So I can kind of do that indefinitely. So I've kind of showed that briefly. One of the other things that I've also built into this platform is the ability to exchange. And so again, I have some amount of Ether. That's kind of the Ethereum's currency. It's worth about $250 US right now per Ether. And then DAI again is the $1 US kind of currency. So I can go and say, oh, I want to buy 100. Kind of I want to exchange from my wallet I want to buy 100 more of these US dollar pegged currencies. I'll show you briefly, kind of this also pops up another confirmation. This is completely incorrect in terms of the actual pricing because we're on a test net and the markets are not real markets, but that's kind of another functionality that's available here. And so I just wanted to also briefly talk about kind of the possibilities here, right? One of the really great things about the kind of blockchain ecosystem is that people build things in this kind of permissionless way all the time. Like for example, this is Maker, which is again talking about this stablecoin. And this is actually linked on their official website, but this is built by some random person that is completely unaffiliated with the company that runs it. And they basically made the official dashboard for them. This is another really interesting, this is not connected, but it's okay. This is another platform that allows, it's very similar, that allows you to use Compound that again is completely unaffiliated with the actual company that runs Compound. And so again, this idea that people just build things, and because it's permissionless, because you and I can build this exact same thing if we wanted to, there's a lot of interesting activity going on in the ecosystem. And so let's just go back briefly to kind of explaining how this all works. And so again, this is all ultimately JavaScript. And mostly everyone who develops in this space uses kind of this library, we call it web3.js. And I encourage you to kind of read the documentation about it. And it's pretty well documented, even though there's a lot of hiccups, to be frank, around it. And let's look at some of the code that makes this happen. And so there's really, again, we're talking about kind of these 3 steps that's really required in order to make this all happen. And one is, again, connecting to Ethereum. So kind of when we first launched the app, you have to kind of press and say, oh, I want to connect. And how do we do that in code? Secondly, you have to initialize a contract. And so in order to interface with the actual contracts, smart contracts on the blockchain, you have to kind of wrap basically create a JavaScript object that allows you to do that more easily. And this library gives you a really easy way of doing that, and we'll talk about kind of how. And then thirdly, you can just call the contract functions once you have all that set up. And so for example, when I lent money, that was just one single function call. So in order to make a request, we need to be connected to an Ethereum node. And that kind of little Fox thing out there, that's the software that allows me to do that. And so this MetaMask is probably the most popular product if you want to use Chrome or Firefox or some of these other browsers. Brave is like a browser that was built specifically for this. And fun fact, Brave is currently being created by Brendan Eich, who's the creator of JavaScript. And so he's quite optimistic about this technology, and I don't know, Brendan Eich is, again, the creator of JavaScript doing this. So again, by connecting to this backend, and again, it's a really easy function, you just call new web, and window.ethereum is basically it's a window, you have access to the window object when you're in a browser, and we actually, this MetaMask plugin actually injects it into it. And so it makes it really easy. Again, all you do is you just have 2 lines of code to do that. And that gives you this backend access to this Ethereum node. Secondly, we have to kind of create, again, and instantiate this contract object. And again, this makes it really easy. There's really only 2 pieces of information you need. There's something called an ABI and an address, a contract address. And again, Web3 gives you the library to say, okay, I just need these 2 pieces of information. I can work with Ethereum from that. And so what is an ABI? So an ABI is an application binary interface. And so that sounds very similar to API because it is very similar to an API. It basically documents how the function works, right? And so like, oh, I expect this function is called this is how you use the function. It's a bunch of JSON. And again, if there's a protocol or company that wants you to use their smart contract, they will have this publicly on their website and say, copy this. This is what you need to work with my contract. Secondly, you need a contract address. And so some of you may be familiar with this idea of address. So if you have an account, you have a wallet, your own balances on Ethereum or on Bitcoin, you have an address. And again, just like a wallet address, every contract has its own address. And that just tells the platform, like, where is my contract code located in kind of this big mumbo jumbo that is Ethereum right now, this massive database. And therefore I know where to call it, right? So with these two pieces of information, then we can kind of call a contract function, right? So one, we tell the contract object, these are the functions that are available. Two, this is where the functions are located on Ethereum. Then I can call the actual functions themselves. So we do that through a methods attribute. And so that maps directly to what you have in your API. And so again, if someone really wants you to use their contract, this is going to be really well documented. And so again, this is the contract that I'm calling, CDI methods of, and then the method is called balance of underlying, and that returns a result in JavaScript. And so it basically returns it in JSON or whatever return type it might be. So you might notice kind of in this, there's kind of two different ways of calling it. There's something called call, and there's something called send. And there's a difference. So one, a call is effectively getting the data from the database. It's a getter function, basically. So when you call something, when you use a getter function, you don't need all 25,000 computers to go and tell you what that value is. You can just go and access the database available on one of those computers, and they can tell you. But when you need to change the data, when you need to change state and update something, other way around, you need to make a transaction. And this actually costs money on Ethereum. It costs, there's a currency kind of we call gas. That's basically, because I need 25,000 computers to run this code, please pay a certain amount to do this. And it's fairly trivial. It used to be, again, there's a lot of kind of problems with this as well, but this call, this send transaction actually goes and makes it so that all 20,000 computers run this code and confirm it. And so that's really all you need, right? So one, we connect to Ethereum through some type of node and through one of those two pieces of software, MetaMask, Brave. Two, we actually go and tell kind of this contract object, this is what kind of methods you can call, this is where the code is located, and then three, we can just call the functions. And so again, that's why I do believe it's actually much easier than kind of most people think about it as. And so again, please feel free to take pictures of this. There's a bunch of really, really great learning resources if you want to kind of learn how to develop in this. I don't know if I'll wait a few seconds to kind of let everyone do that. And then there's also a bunch of other projects. So again, I built on two different projects, but there are dozens and dozens of projects that are really interesting, that are really well documented kind of APIs about how to use their code that we can all build on if we want to. So thank you very much. That's my email and that's my social handle everywhere. I'm happy to talk about anything associated with kind of all of this blockchain stuff. If you have any more questions, please let me know. But thank you very much for all your time.